Hello guys, I've decided that I'm going to redo the implementation of this OBS window can go away. That I'm going to redo the implementation of type functions just to make sure that it stays that it still passes the test and the test rate and that it stays mergeable without problems. So what I'm going to do now is to selectively copy things from the work I've already done. For example, this can also help me to make sure that we don't do a few mistakes that we did before, and to make sure that we stay with the easy way of doing things. So let me write my first example, or rather yeah, I think I can just copy my example from the forums, because we definitely want things that have been mentioned on the forums to still work. And one of them, maybe not the member names one, maybe the first one that started all of this, the fully qualified name one. Isn't that here? Is it on the first page? Could be. Okay. I think I posted a second version, which is a bit better. Yeah, so let's start with this one. Let's try to get this code working. And so we take this, we says test fqn, like that, and we would like this to work. If we build this with as it is right now, we run it and we get no identifier for declarator p in line 4. So that's, this one surprisingly works. I would like to know what this is passed as, but since I have already done this, I just have to find in my patch where I did the change. In this case, this would have been a change in the parser, so all we have to do is to look for parse_d. There's a bit of debugging code for it, and this here is a change that has been done to the parser, but it's really just that at line 441. So let's see if that is still applicable. Yeah, still seems to be completely applicable. So all we do here is we paste this one in. Like this. We remove the pluses and remove this to here. Not quite More like that. Okay, just an annotation, and maybe have another. Okay. So what we're doing here is actually very straightforward. At this point here, we already know that the current token is alias, so we have already matched the alias, and then we look for an identifier, and if the next symbol after that is semicolon. So if we have something that looks like alias a semicolon, that would match for this, and then we would know that we have an alias variable. So if we now recompile this code, it should be working. So yes, so it does actually parse now, and it dies on the static assert because it doesn't think that FQN is a template. And it's correct, FQN is no template, FQN is a function. So what happens now if I call this function? I get an assertion failure, and it complains about not knowing the size, and in here we can see it doesn't know the size of a variable declaration. That is most likely because it doesn't know the size of an alias. So let's see how it even gets to ask for the size of the alias. Okay, so it calls the interpreter, which means it has recognized that this is a function call of FQN. To have a little bit more insight what's going on, I'm going to enable the logging functionality of the interpreter. It's just a debug log. We comment that in, recompile, and then we should have some logging output, and here we can see it has a call expression, which is FQN cast alias XX, and we see that because FQN expects an alias and gets a symbol, this cast is automatically inserted for us. If we look at our diff to stable, there's really not much we have done. We have changed the parser a little bit, we inserted a serial for better debugging, and we commented out the log to see a little bit better what's going on. So we interpret that, and during the interpretation we visit a variable declaration that gives us a bit of grief, because not knowing the size, one candidate, as I already said, would be alias, since aliases don't have sizes. So that happens when we visit the declaration expression in 5011. So why don't we just go there? Okay. Yeah, so somehow this doesn't look like we're at the declaration expression here, does it? There's an index expression. Oh. We're at expression sum 511. So, okay, here's the deal. Let's see, test of Q. Okay. One thing that we have to be aware of is this code. It cannot go through the normal path that a function would usually go, because a function expects all types to be resolvable, which in this case this isn't totally true. Like, for example, this trace expression, it would expect this identifier to be resolvable while looking at this function, like before interpreting it, and that doesn't work since this alias is a variable, and it's a variable that represents a symbol. So it represents something that is usually always statically available at compile time. However, for type functions, that is not the case. And therefore, we have to exclude expressions as soon as they try to work on type functions. And I think in this case we get a problem with the actual alias. So let's go into the expression semantic, and let's get the expression semantic to tell us where it is when it dies. So we set this log semantic to true, and then we brace ourselves for return of output. Well, maybe it won't be that bad because we are falling relatively early, but let's see. So we can see there is a ton of output. The reason being, why does it have... Those are register names. Where do they come from? I have no idea actually, but this seems weird to me. I've never seen that before. Oh, still, that's fun. So we see semantic being applied. Things being done. And then we go to interpret. We try to resolve what the variable t is. We look at the var exp t, and we have a string exp semantic. that is already a T. And then we look at the declaration P, and there we die. So why? Where does this string x t come from? Well, it comes from here. The string of t, if it would be int t or anything but an alias, the string of gives you the name of the actual thing. For an alias that doesn't work, since aliases are transparent. So we will have to make this work, and maybe we should make the string of work first. In order to do that, we have to look at where this t gets assigned. And the only thing we see, oh, there is an una semantic, and before there is a .idexp semantic on the t.stringOf. And that is a semantic that would be running on an alias, t alias, a type function argument, and we can't do that. So let's see where this .id expression semantic is. It's an expression semantic that makes a few things easier. .id exp : semantic. Okay. It doesn't do much. The only thing it does is it calls semantic y, and God knows why it's called semantic y. Should probably be called resolve symbol or something like that, but apparently it isn't. And we can now look in the patch we already have what we did back there. And with a bit of luck, there. We now just look for that, and we see that we added something here. Why did we add it here? Because here is the moment where we can change things after exp has been partially resolved. So it first calls semantic x, which I guess does mangle off. It does mangle off, and what else? Oh, this is interesting. If this is correct, then tuple.offset of, it says it distributes it. I have to check this out. Give me a moment. I didn't know that. There we go. Let's make something that would give us a tuple. Holy fuck! I never knew that. This is awesome. This is seriously awesome. I highly doubt that this is documented on the website. This cracks me up. This is great. So, sometimes you discover things you didn't know were possible. I can't. This, whew. This is actually very good. Knowing that that special case exists, I can simplify a bit of code, but why does this even exist? I have no idea. Let's quickly finish up. So what this thing does, it handles tuple.offsetOff. It handles going out of bailing out for templates, and it handles doing that for type variables. Not for type variables, for expressions that are not yet resolved. Any expression that doesn't have a type is actually not resolved yet. So I wonder why it gives the error expression E does not have the property X. That is not actually the correct error. The correct error to give here is expression E couldn't be resolved, and therefore I can't tell you if it has the property. Like, that E1 doesn't have a type just means it's not resolved yet. Perhaps we should actually do that. Like, let me try and see what happens if I just change this error like that, and then I do rs.set like that. And we see no property for Z. No property Z for type test tuple S. So this expression, this one here doesn't get displayed. And I would strongly recommend to simply write that, because this error message makes no sense whatsoever. It should be Actually, I don't care. Let me just see what I just said. What was just that? Oh no, it wasn't just that. And looking at the one that I didn't put the parser. Which is the parsing for the alias variables, and yeah, the rest we can stash, because now we know that we have to change stuff in semantic X or semantic Y. I think we can go either, but come on. Semantic Y. Don't tell me there are multiple semantic Ys. Okay. We do semantic X. After semantic X, we either have what we need or we don't. Yeah, so let's just repeat what we did before, and I will explain what it does after I've pasted it in. That would be this. Basically what we do is we check if the expression has a type yet. If it does, we do yeah, let's just remove the pluses and then let's the auto indent do the rest, and I'll explain when the code looks nice on the page. There is not really much to know here, but I'll tell you anyway. So added view. I think it was added format selection. I love this too. Yeah, thanks to the guy who wrote it. I think this printf we should remove for the time being and mark it as being a debug line. And now, so first we check that the type of the expression before the dot, which is E1 is what's before the dot. Ident is the identifier after the dot. We check that we have resolved what this is. We check that the type is resolved, and when it is resolved, we check that it is a t-alias. If it is a t-alias, we set the type of the .id expression. When we set the type, that tells the semantic path that we are done resolving. Anything that has a type is by definition completely resolved. So that will cause this expression to pass on. And we can then, in CTF-E, we will get an error that an expression has made it there, and yeah, that's what should happen. So let's actually I may want to note down that there's something fishy going on in semantic X. Yeah, but for that I would have to trigger a forward reference that would make that would cause the symbol to be unable to resolve. And I'm not even sure if we can hit that place, but if we could hit it, we should change the error message to something that makes sense. But for now, let's stick to this. We should now see a difference when we compile the test FQN, because we should now no longer see the T, and if you can see, it says unisemantic T string of. We do no longer have the string variable T inside of this, because we didn't rewrite the .id expression with a string, which is what the ID expression semantic would have done. So we no longer do this. We don't do the read write. Now we still have the problem where we go into the declaration expression alias p. We're trying to get the size, and we die on that. If we look at what we did here, it seems like a typo declaration. If we look at what we did here, the expression semantic, there is quite a few changes that we did. Quite a few that we'll still have to do. This one we just copied in. Parts of change we also did. Okay, it seems like I can't find the code in the patch that made this happen. But for sure we have to find a way to not do a semantic on alias p, and that happened in expression semantic 5.1 where we do not want to do this. So maybe we can just go there, declaration exp, there we go. This is the declaration expression semantic, which we should see here, and this means that when we're here, we have to, if something is a t-alias, we can't move on. So basically E has a type. If E has a type, we know that this is resolved and we return. The declaration expression has a declaration in it, and that declaration is a D symbol which we assign to S here. We check if it is a var declaration, and if it is a var declaration, we call D symbol semantic on it. And I think in this case what we have is a var declaration, and I do not think that we have a type yet, but we can check. No, actually we should have a type. We should have a type on the var declaration, and we can just say if v dot is alias type if v dot type is alias type, return exp. And that would just say that if we have a variable declaration that declares an alias, we just bail out of here. We don't do anything. But that means we haven't set the parent of the symbol, and maybe we'd want that, but then again I'm not sure if that will change something, so let's rebuild. And we can undefined identifier exp, and we cannot return anything from here. Yeah, that's true. So maybe we just return if this is an alias type. I'm not sure if this is the correct thing to do, but we can do it. And now we will do the declaration expression semantic, and after that we will segfault while trying to resolve properties, apparently. So I'm quite sure that this is not the way I went, and I'm also quite sure that the expression semantic does always return, it returns an expression. Right, it sets results. That's what we have to do here. Instead of just returning, we have to set result to the declaration expression. And that passes the declaration expressions through when there are aliases. Apparently the name is not exp, it's e. That's fine. And now we should just pass it through without processing it further. And we can see that we cannot resolve type for alias p. It's an undefined identifier, and therefore it will not even actually try and interpret the function, since semantic already fails. Like that the type can't be resolved. It's an undefined identifier, and so on. So why can't it resolve the type for alias p? Why does it say that? It says that because we're assigning e to the result. And e has no type. So what do we have to do? What we have to do is to give the result the type of the variable. So what we have to do is here result dot type equals v dot type. Now the expression does have a type and we won't get the error. And we indeed do not get the error that it doesn't have the type. Rather, we get the error that the variable p is forward referenced. So what's that about? So the variable p is forward referenced when it couldn't be resolved. And here we went and thought that we could just give it the type t alias and be done with it. Well, the whole thing is not that simple. When we see the declaration expression, we also have to actually declare this variable. And the more I think about this, the more it occurs to me that perhaps doing this way is wrong, because this is not how I did it last time. This is not how I did it last time. So let's see again what happens if I don't do this. I think we do not get an error, we do get a segfault. And we do get 1 while we're trying to get the size of the thing. And do symbol sum. So the var declaration and the symbol sum in 12.7.5 complains about this thing not having a type. And we can maybe do something about that. Yeah. Go to source, dsym, source dmd. Symbol sum. There it is. And it complains about line 12.7.5. 12.7.5 in here. I do remember having fixed that problem here. And the problem is not actually that we can't declare something of type alias. The problem is that in order to compute the default declarator, we need to know if the symbol does not have an empty size, because if it has an empty size, we can do all of this. And I think what I did was, so if this if goes, we provide a default declarator. And after that we look at the init expression, if there is one, it looks like. And what I did in my previous patch was, when we were a type function, I didn't ask for the size. So that was quite tricky to work out how to write, so let's go over this. So if the D symbol does not have an initializer and the D symbol's storage class is neither static nor G shared nor extern, in which case we do not provide a default initializer at so that not I am not 100% sure how this one binds. At all, and I don't know what FD is. FD normally stands for function declaration. Yes, it's a func declaration. So if it is not static G short or extern, okay, it doesn't have an initializer. It is not G shared static or extern, and it is not a field, a for each, a parameter, or a result, because because you can't initialize a parameter or an in or a field. This is weird. I don't quite know what it means. And no, or it's an out variable. Yeah, so if it's neither a for each, a parameter, or an out, and the size is not 0, we provide a default initializer. Alias variables do not, or aliases, whether they're variables or parameters, they do not have a size because technically they do not exist. So they also cannot have a default initializer. What we do is I think this is still for things that do not get it, but I don't really care at this point, so I will just say and dsym the type dot is alias. What was the check I did here? Oh, yeah, we do ask is alias type is not alias type, and that should give us get us out of this problem. And we see it does. We no longer have the problem that it sec faults on the size, but we do get an error that alias t is not callable without any arguments, and it's missing the argument for the parameter t in line 10. Let's see if that can be trusted. So in line 10, there is p equals parent p. There is not a call of fqn. The call of fqn is in line 24. So what's going on here? And I have to say, I do not actually know it does not seem like the interpretation would have had started this here are semantic of the equals method, which got pushed into the runtime, and now everybody has to read that garbage. So we get upon calling and resolving fqn, we see that function fqn alias t is not callable using the argument types, and that's weird. This is as if the function, the thing would resolve to, oh, you know what happens? Because we haven't yet really implemented the type function semantic, it complains about line 10 and the function not being callable with the wrong parameter, with that parameter type. Okay, here is what happens. What happens is we assign p to the trade's parent, and we can even show that by doing trade message. That should normally say alias, but yeah, it should say alias actually. Somewhere on standard error we should see alias being emitted. If we are lucky. And yeah, when we redirect the output, we see alias here. Missing argument from parameter 1 alias t. So we want to assign this to traits parent P. Traits parent P in here is this, right? Because that's the parent of this. So what actually happens is this. Traits parent P is FQN. So this gets replaced with FQN. And when you do that, what should happen in the type function is that you assign the symbol variable P, the alias variable P to FQN. But what happens in regular D is this. It thinks that this is a parenthesis-less call and will therefore call the FQN function rather than assigning it. So that explains why we get that this call can't be done. So that means this traits parent gets evaluated before we get the chance to intercept this traits expression as a CTF function. So what we have to do is we have to go into the traits semantic, which is a special part of the expression semantic, and we have to say, if you ask for a trait of an alias parameter, then please don't do anything and forward this expression to CTF. So just set the type to what the type should be and forward it to CTF. For that, we can go to traits.d and we can look where the parent is resolved. So here, by the way, we have a name, a list of all the names that something can be, and we just look where parent occurs. We have here the e.ident equals parent, and for now that should be enough for us. So what we want to do is we want to get the type of the first expression that is being passed into traits, because traits can take symbols, types, and expressions. We cannot actually be sure that the objects that we pass in will all be expressions. That's why traits expressions have their arguments. The arguments here. That is an array of objects, and objects is one of the shorthands. It just means array of root object, and root object is the root of the inheritance hierarchy. Technically this should now be S node, but well, the whole changing the hierarchy of the DMD compiler, the internal class hierarchy, was started and never really finished. caused a few problems for me personally, but I'm over it now and I won't rant infinitely. So what we can do to check if this thing, whatever it is, would be a t-alias is to say get type of O, and we say if auto t equals get type of O, because this could come back as null if there is no type, but if there is one, we want to do if t alias, I always forget what we call the function that I wanted. Alias is alias type. If t is an alias type, then we want the type of the result here. We just set the type of e. We say e.type equals t-alias, because we expect to get a symbol out of the d parent. That should be a symbol. Well, technically we can do type and so if you call that on a t-alias, well, in theory you could have a pointer of a t-alias, but let's not worry about that now. Let's see. That'll crash when it happens, and then we'll take care of it. We set the type to t-alias the expression, and we return the expression as is. Yeah, I think at that point you just return the thing. Okay. Since that is that, we can now try further compiling it. And now, no property type. Oh right, yeah, we already got a type, so we just have to check if that the ty, which is the kind of the type, is the t-alias type, and if it is, then what? Oh yeah, t-alias is a type enum. That is not actually what we want. What we want is type.t-alias, which is the basic type of alias, which is the type of caps and symbols. So now we go a little bit further. This stuff here is being interpreted. I think we disabled the lock. So this stuff is now being interpreted. We want to interpret this call. But we actually can't. We get an error that the variable xx cannot be read at compile time, where and we see here that we call fqn with the cast alias xx. So the question is, what's going on here in line 25. We certainly can give FQN the symbol XX. But DMD doesn't yet know that casting it to alias means that we want the symbol. It thinks we want the value of XX, which then means that we cannot resolve it. But perhaps we should do this another time. It is getting late.